Hi, welcome to your last video of 5.4. This will be the last transformation we talk about. And let's just do a quick review. Don't get dizzy on me. I'm going to go all the way up to what we've been talking about. So we learned about how to graph our sine and cosine graph. We talked about when we have a value in front of our function, it turns out to be our amplitude. We also talked about if it's a negative, it talks about a reflection. We also talked about when we subtract or add things on the end of our function, it shifts it up and down. If we subtract or add things inside the function, it shifts it left and right. So now, what happens if we multiply our inputs? So let's go ahead and fill out. We know the fact that this amplitude is 1. This amplitude is also 1. And what is this amplitude? It's 8. Don't say -8. The negative talks about a totally different thing, which is a reflection. I know for a fact my period is 2 pi. I'm not sure about the others, so I'm going to go to Desmos. I'm going to get rid of these guys. And it looks like I had y equals sine of 2x. And let me go ahead and change this guy to sine. All right, let's just focus on those two. Let's change this color. Okay, here's your normal parent graph. Now compare it to this black graph. Do you see how it's, okay, there's 2 full periods. And now it looks like, whoa, those periods went ahead and doubled on me. Does that make sense? If you're looking at 2, it looks like we're going through our inputs twice as fast. Now, if we look at the other one, which I forgot what it was, 1/2 x, okay. It's going to be y equals, I'm going to just leave off that -8 so we can focus on one thing at a time. 1 divided by 2, and it's going to be x, no, not below. We want it to be right next to it, x. And let's change that color. Now look at that. Okay, so if I take away that one, it is taking way longer to get through a cycle, through a period. Where this one, whoa, or the frequency of the wave is increasing, right? Where this frequency is decreasing. So what that's saying is, for this one, the black one, you're going through your inputs twice as fast. For your green one, you're going through your inputs half as fast, if that's it's taking you half as long to get through them. So how we figure that out, that looks like our period is being affected. So what you do every single time to figure out your period, you take your original period, you divide it by whatever is inside your parentheses. So we end up getting pi. So let's check that out visually. I'm going to get this away and just focus on this one. So it doesn't matter where you start. We're looking at sine, so it looks like I'm going to choose this point, 0, 0. Remember sine, you have a high point, midline, low point, midline again, and that takes care of one full cycle. So if you pay attention to that, where we started at 0, 0, when we ended at pi 0, that length of that cycle is pi. Where this one, start here, 0, 0, we have a high point, and look, it doesn't even look like I'm seeing everything, so I'm going to zoom out. So we have a midline, high point, midline, low point, midline. Oh, and then it's going to start repeating itself. So let me take away these. Well, from 0, 0 to 4 pi 0, that took it That length is 4 pi. So your period for this one is 4 pi. And how you find that algebraically is you do 2 pi, always your original. You divide it by whatever is inside that parentheses attached to that x. And to refresh your memory, when you divide by fractions, you multiply by the reciprocal. And what do you know? You get 4 pi. So what happens here, if it's being bigger than 1, so that's like this case, our graph was compressed, right? So this is a horizontal compression by, this is a little bizarre, 1 over whatever your b is. So like for instance, this is a horizontal compression by a half for this one, okay? Now this one, I changed the variables on us last minute, so that's why that omega stuck. But we're going to change that omega to a b so it's consistent. This is when it's between 0 and 1, which is like this, okay? Well, that one, if you can remember, was a horizontal stretch of, or sorry, I should say by 1 over b. So this one would be a horizontal stretch, this one, looks like it would be by 2. All right, so for instance, I'm doubling the period. Here, I halved the period. We're going to do lots of these in class together so it gets better. So let's graph some of these guys. So this one, we're just going to focus on f of x. Our amplitude for that one is 1. Our period, well, hopefully we're all right with realizing, okay, well, my x is being multiplied by something, so that means my period's being affected. It's going to be 2 pi divided by whatever's inside that, which is a 2. So you end up getting pi. Let's add our midline. Our midline for this one would be y equals 0 because there's no plus or minus on the end. It's not going to horizontally shift either because I have no plus or minus in the inside of the parentheses. So being consistent, I'm choosing my scale based on this information. So I'm still going to work in quarters. Makes life real easy. Working in quarters this way too. But instead of me listing that as 2 pi, I'm going to list it as my end of my period, which is pi. It makes graphing so much easier. Then, because my amplitude is just 1, I'm going to go ahead and do every other tick mark. So I'm graphing cosine here. So that means it starts at a high point. And let me put my midline there just so you know. Hits the midline, low point, hits the midline, high point. On the other side, midline, low point, midline, high point. And what do you know? We have our transformed graph. Now, it might be like, wait, it looks like our original graph, but this is no longer 2 pi. So I'm showing the transformation because I just changed the scale. This one, amplitude for g of x, that will be 2. My period will be 2 pi, whatever it originally is, divided by 1/2. We did the work above, so I end up getting 4 pi. And our midline is y equals 0. So to give myself a scale, 1, 2, 3, 4. 1, 2, 3, 4. I'm going to change colors just so it looks different. And 1, 2, 1, 2. Sine starts at your midline, so giving myself the midline. Starts here. Then, oh, what did I not do? I don't have a scale on my x-axis. I'm always going to choose my last tick mark to be whatever my period is. So I start at the midline, and then I have a high point, which goes all the way up to 2 because it's 2 units from the midline. Hit the midline again, low point, midline. Following the pattern on the other side, I'll have a low point, midline, high point, midline. And here you have your good old, and make sure with your sine graph they're curves and not points. And you might be like, I don't see the transformation taking place, and that is true because all we're doing is swapping out that 2 pi to be a 4 pi. If you were comparing it to the original, it would get a little messy because you would have so many things on top of each other. But you can see if we go back here, let's go ahead and make this y equals cosine x. Let's go ahead and make this y equals cosine 2x. You can see how it's being horizontally compressed, and hopefully you're okay with it, by 1/2. You're going through the inputs twice as fast. So my period, if you follow it, here's the beginning of a period, go down and up, is going to be pi units long for that green graph. Here you can see the transformation where here we're changing the scale to make our lives easier. It's really wonderful. So we're going to put all of this together. What I do want you to take away from this is that these things are known as sinusoidal functions because cosine and sine, they look pretty darn similar. They're just a shift off. We'll talk more about that in class. Now, here are all of the transformations we talked about except for a reflection piece. I'm going to have you pause the video and come back to it after you try it on your own. So I know my amplitude, you're going to hear my dog bark. I am very sorry. We're going to try to ignore it. My amplitude is 3. My period is 2 pi over pi over 2. And clean that up. I'm going to do 2 pi times 2 over pi, because I'm multiplying by the reciprocal. And then we're going to go ahead and reduce out the pi's. So weirdly enough, we get a period of 4. We know our midline is y equals 1. All right, so if I'm going to start graphing, I'm going to go ahead. Again, this is going to tell me my scale for my y-axis, and this is going to tell me my scale for my x-axis. So if I do quarters, 1, 2, 3, 4, well, that 4th tick mark, I'm going to make a 4. 1, 2, 3, 4. I'm going to go up. I think I'll have enough. I should just do 1, 2, 3, 4, 5, considering I have to shift up and stretch by 3. My first step, I'm graphing my midline. This is not part of the graph. This is just me helping me plot things. I'm working with cosine. That means I start at a high point, not the midline. And so this tells me I'm going to go ahead and instead of starting at the high point of 1, it looks like I'm going to start at the high point. Well, again, this turns into my x-axis. So from there, I'm going to go up 1, 2, 3. So I start at a high point at 4 because I'm 3 units up from 1. Now, I don't have to worry about this pi over 2 because it's taken care of with my scale. And that's the most wonderful piece of news. So then just following the pattern of cosine, hit the midline again at this unit, hit the midline low point 3 units down, 1, 2, 3. This coordinate, midline again, last coordinate, high point. Finish that pattern on the other side. Here, midline, high point. So again, I'm going to connect. Ooh, let's see, pretty. Make sure, I'm getting better with this technology, but you make sure your lines actually go through your coordinates. That's a huge one. And I have not been doing this every time, and I really should. I should always label 3 coordinates. So here, looks like, okay, that is going to be 1, 2, 3, 4. So that is 2, comma, -2. This coordinate here is 0, 4. And then you just choose another one. I'll choose this one, -2, 2. And if you ever want to know you're right, use some algebra. So let's check to see if this coordinate's correct. F of -2, 3 times cosine of pi over 2 times -2. Close that, and I'm going to add 1. So I get here 3 cosine of, well, these would reduce out, so now it's -pi. What's cosine of -pi? Well, that guy is going to be a -1. 3 times -1 is -3. I add a 1, and yay! I didn't write it right, so I'm glad I chose that one, so I caught my mistake. It's -2, so that checks out and works. All right, I will see you next time.